Artificial gravity is a concept that has long captivated the imagination of scientists and visionaries like Elon Musk, and represents a critical puzzle piece in humanity's quest to conquer celestial wonders, from the moon to Mars and beyond. As we venture into the cosmos, the absence of gravity in space poses profound challenges to human health and well-being. Musk's ambitious SpaceX plans to establish a presence on Mars has highlighted the need to find practical ways to create artificial gravity, as this will help reduce the harmful effects of long-term weightlessness on astronauts. The pursuit of artificial gravity promises to revolutionize space exploration, paving the way for sustainable colonization of extraterrestrial bodies. Let's explore what it would be like to live in a world where artificial gravity is the norm. What is artificial gravity? In a genuinely tangible sense, the rotation of a spaceship generates a gravitational force known as artificial gravity. This force imbues weight to the human body, weight indistinguishable from the natural gravitational pull of Earth or any other planet due to its sheer mass. For many years, science fiction authors have envisaged spaceships that rotate to create artificial gravity. This type of gravity benefits astronauts during extended space missions, when they are not weighted down by the extra mass caused by the spaceship's acceleration or deceleration. Instead, they are in a weightless state while the craft coasts, nullifying the effects of gravity. Within science fiction, two examples of artificial gravity have captured the imagination of audiences. The first is seen in the 2015 film The Martian, which showcases the interplanetary craft known as the Hermes. This vessel features a large, wheel-shaped section that rotates during its journey between Earth and Mars. Upon close inspection, it becomes apparent that the up direction for the astronauts inside the Hermes is always toward the center of the wheel. Conversely, the down direction is situated at the rim, the floor. The second example of artificial gravity is depicted in the 1968 epic 2001: A Space Odyssey. This film showcases the Space Station 5, a spinning station that generates artificial gravity equivalent to the moon's gravity. Using this artificial gravity, the characters in the film can easily navigate their environment and complete their tasks efficiently. Why do we need artificial gravity in space? When we're out in space for extended periods, it's not just about being comfy. There are actual health risks that come with weightlessness. Our bones can lose strength and become prone to breaks. Our muscles can shrink and weaken, and our bodily fluids can shift around in ways that mess with our hearts, lungs, and nervous system. Recent studies have shown that some astronauts may suffer permanent eye damage from prolonged time in space. If we ever want to have normal pregnancies while on a space mission, we'll need to figure out how to create artificial gravity. It's a no-brainer that any spacecraft carrying people around the universe should have some way to rotate or simulate gravity. NASA and other space station officials have been researching this topic for years. They've been exploring the idea since the 1960s. The idea involves using rotation to create the illusion of gravity in space. While funding and enthusiasm for the project have fluctuated over the decades, there was a surge of interest in the 1960s when NASA was working on sending humans to the moon. Back then, NASA's budget was nearly 5% of the federal government's budget, 10 times more than it is today. It's exciting to think about the possibilities of artificial gravity and what it could mean for future space missions. NASA has focused little on artificial gravity research over the past 50 years, but scientists inside and outside the space agency are delving into various situations. For example, mice spinning in a small centrifuge aboard the International Space Station survived without problem. And here on Earth, humans learn how to adapt in spinning rooms. The Ashton Graybiel Spatial Orientation Laboratory at Brandeis University has one such room, and the DLR Institute of Aerospace Medicine in Cologne, Germany boasts the only DLR short-arm centrifuge Model 1 in the world. This incredible piece of equipment is dedicated to researching the effects of altered gravity, especially regarding health risks that occur in microgravity. How does it feel to be in an environment with artificial gravity? Have you ever been on a wild carnival ride like the spinning teacups? If so, then you've experienced the mind-blowing effects of artificial gravity. Once inside the spinning object, you'll be pulled toward the outside wall due to inertia. Your body will resist the change in motion of the object spinning around you, and you'll feel an incredible force that seems to be pulling you toward the outer edge of the teacup. It's called centrifugal force, a thrilling sensation you will remember sometime soon. Centrifugal force is just inertia. But here's a fun fact. This imaginary force works perfectly fine if you need artificial gravity. All you need is either a small ship that rotates fast or a big ship that rotates slowly. Either way, the spin would pull you towards the outer wall feet first. This is better than magnets because your whole body would feel the effect. Plus, your blood and fluids would move through your body like on Earth, and your bones and muscles would feel the pull when you walk or run. Pretty cool, right? An O'Neill cylinder, invented by physicist Gerard O'Neill, is an extensive rotating system designed to be used as a space habitat. The cylinders would be aimed toward the sun and spin in opposite directions to hold them in place. They are huge and could potentially house up to 1 million people. The founder of Amazon and Blue Origin, Jeff Bezos, has expressed interest in constructing O'Neill cylinders, but this is a distant possibility. One major obstacle is determining where to construct such a massive structure. While it could be built on Earth, the challenge lies in transporting something 32 kilometers long into space. Unfortunately, this would require significant funding and numerous rockets. Another potential solution would be to construct habitats in space, as it is currently more feasible to travel to Mars than to build structures in space. Smaller rotating objects can create the same gravitational effect as O'Neill cylinders, but must rotate faster. Prolonged exposure to a rapidly spinning object may cause an unpleasant physical response. People in or on rotating objects experience the Coriolis effect. This deflection occurs when objects not attached to the ground travel at high speeds or long distances relative to a rotating planet. The Coriolis effect is a fake force caused by inertia and is noticeable in a fast-spinning spaceship, causing arms to be forced to one side when lifted. The impact on your arms is insignificant compared to your brains. Catherine Brettel, an aerospace engineer at the University of Colorado in Boulder, explains that individuals inside a rapidly rotating cylinder experience the cross-coupled illusion. This phenomenon occurs when someone is on a spinning ride or in a spinning space station and feels fine while looking forward. However, when they turn their head, they experience a tumbling feeling known as the cross-coupled illusion. Scientists have found a way to help people overcome motion sickness by slowly increasing the speed of a spinning chair over time. In a study, volunteers could tolerate being spun around more than 11 times per minute after 10 training days. After 50 days, they could spin more than 25 times per minute without experiencing any nausea. It's possible to create a rotating room on the space station to generate gravitational force of approximately 1 g, the same as Earth. The room wouldn't need to be large, just around 2.6 meters in diameter, making it attachable to the International Space Station. Brettley suggests having a pair of modules rotating opposite each other, with the astronauts standing on a treadmill while the system is in motion. This would allow them to exercise in the rotating gyms and maintain healthy muscles, bones, and circulation. They would float throughout other space station areas when not in the gym. Artificial gravity is often perceived as a far-off technology, but it doesn't necessarily have to be. It only requires extensive and expensive systems like O'Neill cylinders to benefit astronauts. Overall, life inside artificial gravity is a fascinating topic that has captured the imagination of many people. As we continue to explore the possibilities of this technology, it is clear that many potential benefits will be gained. From improved health and fitness to increased productivity and efficiency, artificial gravity has the potential to revolutionize the way we live and work. However, it's crucial to proceed cautiously and ensure we fully understand this technology's potential risks and challenges. With careful planning and implementation, we can create a future in which artificial gravity is a safe and reliable tool that enhances our lives in countless ways. We hope you enjoyed this video, and thanks again for watching. Please make sure to share your thoughts below, and don't forget to subscribe to our channel for more thrilling space updates. See you next time.